Hi, thank you, everyone. Yes, my name is Matthew Kenton, and I'm a developer at the work cooperative in the UK called Outlandish. We're based in London, and we develop data tools, prototyping, and campaign websites. And our primary technologies are PHP and Node.js, and we commonly use WordPress, which is the use case that I'm going to be showing today. When we're talking about WordPress at scale, or any website at scale, we'll often want to put the website behind a cache service or system, like Cloudflare or Varnish. But in some cases, this isn't feasible when you're expecting a large number of user interactions or delivering custom content. And in a case like that, MiCADO can respond to the performance of your application to increase the resources that you need when your website is under load. In the example application I'm going to be talking about today, we have 3 containers in a setup similar to this. We have an Nginx container, a WordPress container, which is the one that we'll be scaling today, and then a Redis container, and we use that to support the scaling of the WordPress container. In this example, the Nginx container doesn't have a scaling policy. However, it would be possible to implement a scaling policy for Nginx if your use case required it. To implement a scaling policy, you could add a Prometheus exporter to Nginx, and there are a number available. The one that we recommend is one called Nginx VTS plugin, and that provides very comprehensive virtual traffic information. We're using a custom image with static files for the application, and then we are using the n substitution command to template in Nginx configuration files for different environments. The WordPress container, this one will be scaling, and it's going to be scaling based on the activity in the PHP FPM pool, and those are the PHP processes that will be delivering the content to the end user through the Nginx web server. We're using a Prometheus exporter inside the WordPress container to expose those PHP FPM metrics to MiCADO. And we're using a custom image with the application files for WordPress embedded inside. We're also using the m substitution command to customize both the PHP FPM pool and also PHP ini settings. And WordPress is configured to use environment variables so that the applications can run in different environments. We also have a Redis container. There's no scaling policy on this, and this container is just added because by default, PHP session data, which is what is used when users are logged into a WordPress account, is stored to the file system. And as James has already mentioned, we want to make sure that our containers are stateless. And in this case, we can use Redis as an alternative storage method. In our application description template, there's a number of key points that I want to bring out. Firstly, we have a Kubernetes node port to provide outside access to the Nginx container. And we also expose port 9432, which is the port that the Prometheus exporter is available on. We also have the environment variables that are going to be used to expose, to configure the Nginx container when it gets run. Here we have a list of environment variables used to configure the WordPress application. And these can be changed from environment to environment. And we also have environment variables used to configure the PHP FPM pool. And you might want to change these depending on the use case and the stress that you're expecting your application to be under. And then finally, we can talk about the scaling policy. So this is the scaling policy for the WordPress container that is scaling. And in it, we are looking at the number of active PHP FPM processes and comparing against the max number of active processes available in each pool. And if that rate goes over 60%, then we'll increase the number of containers, and if necessary, we'll also increase the number of nodes as part of the node scaling policy. And when that falls below a safe value, then we can also decrease the number of containers. So now I've got a video that I'm going to show. Can you all see the video now?
Yes, we can.
Fantastic. So I'm going to start this off. So this is starting at the beginning of a deployment of an application that I've just described. And here we have the Grafana dashboard. And here we have the charts that we're going to be using and following to see how the application is scaling. To scale the application, we're going to be hitting it with a number of users using this locust tool. And that's going to start hitting the application with requests. And as that number goes up, we'll start seeing the number of PHP FPM active processes increase. I'm just increasing the resolution here. So now we can see that the number of active processes has reached 100%. And that's because the number of users is hitting the system has increased. We've added a new container now in response to that load. And you can see that the number of active processes has decreased now to a much safer level. And on the chart for request time, you can see that there's a significant drop in load time for your requests. As we increase the number of requests, we can increase we'll see an increase in load on this system. And we'll also start seeing an increase in the number of worker nodes at this point as well. In this demonstration, I'm limiting the number of PHP FPM containers to 2 per node. So at the moment, the MiCADO is scaling up the number of worker nodes. That will take a little bit longer because that requires the creation of a new virtual machine on your cloud. On the chart, you can see the green bar shows the average number of active processes, and then the yellow and blue bar shows the individual number of active processes in each pool. I'll just skip ahead a bit now. And we now see that we've got 2 worker nodes, and also a 3rd container has been added to reduce the load on the system for each container. And very shortly, we'll be adding a 4th container before we start scaling down. And there's our 4th container added. And as you can see, the average number of active processes has also increased. And correspondingly, you can see that there's been an increase in the response time for the requests. And then that's dropped off as the number of containers has also increased. And we're now dropping the number of users down to 1, and we can then show how the system scales down in response. So the number of average active processes has dropped into the green zone. And it'll take a little bit of time because we've just slowed it down for this use case, but you can obviously speed that up based on your particular scaling policy. But slowly the number of containers and then the number of worker nodes will decrease because there's no longer load on the system. And I'll just skip ahead for those. You'll notice that the number of worker nodes increased, and that was just because we were expecting the load to increase, and so we added a new worker node. But that will now drop off. So the number of containers has dropped down to 2 that are active, and the number of worker nodes will also decrease. We dropped down to 2 worker nodes now, and we're down to 1 container, and that will mean that the last worker node will also drop off. So we're left with just the one that we started with, and that's the end of the demonstration.